to right. It's always starting here with the x. If you're tracing the graph starting at the left and it's going up, your graph is increasing. Right? If I start right to left, then it would be decreasing right there. It's always left to right, from small x's to big x's for increasing or decreasing. So decreasing, I bet you can say what decreasing, or the definition for decreasing. Decreasing is telling us as x gets larger, y gets smaller. The values get lower, smaller. So once again, from left to right, so as we go from left to right along the graph, the y's go down, right? The graph goes down. And then constant, basically no change in y. As x gets larger, there's no change in y, slash, it's flat. It's just not going up or down. All right, so let's just go through and we're going to say where this function is increasing, where this function is decreasing. And let's use green as our color. Green. So increasing, this function is increasing. Well, we start here at, and sorry, let me also say this. When we're stating when it's increasing, decreasing, or constant, we're talking about which x numbers is it increasing on. Which x numbers is it decreasing on? Which x numbers is it constant on? So we're using, when we're answering these, we're saying for what x numbers is that happening? So when I'm saying increasing, I'm saying for what x numbers is it increasing? So it's increasing. I'm just going to trace it. I'm going to go, hey look, as I go from left to right, my y value is getting bigger. Cool. And then right here, we have what is called a relative maximum. It's actually also an absolute maximum, but basically it's the biggest y value in this little area. So we go up, and I'm like, all right, cool. Well, after that, it starts going down. So from -1 to 0, it's increasing. And notice I put parentheses around that, not brackets, because right here at -1, it's just starting. We don't know from that starting point what happens before that, because it's the starting point. And then right here at 0, when x is 0, it's going from increasing to decreasing. At 0, it's actually flat on the top. It's like, it goes flat. So it's neither increasing or decreasing. We call this a critical point. You'll study all about that in calculus. But right here at that relative maximum, it's neither increasing nor is it decreasing, which is why we put a parenthesis, not a bracket, okay? And this looks like a point, like it's not an ordered pair. It's an interval from -1 to 0. And then I'm going to put this union symbol. It's a little U. It says this. And then also, so here it's going down, but then after this point, it's going up again. So from left to right, the y values are increasing again, and then all the way to 5. So it increases from x equals 2. Yep, x equals 2, that's 2. Then that's straight. From 2 to 5. Once again, using parentheses because it's changing and it's an endpoint. All right, now let's find where it's decreasing. Well, it's increasing here, it's increasing here. From this point to this point, from left to right, the graph is going down. So from 0 to 2, it is decreasing. Now, if we look at the graph, there are no constant spots. So constant, we can just write dne. There are no intervals where it's constant, so the constant intervals do not exist. Okay, so that's increasing, decreasing, constant. Basically, we're just saying the x intervals where it's going up. So here it's going up, here it's going up, and the x interval where it's going down, right? Okay, so we talked a little bit about a relative maximum. A maximum is the top, the highest point. So we know it's a maximum because if we draw a little circle around it, which we call a neighborhood, None of the other y values in that neighborhood are larger than it, so that makes it a relative maximum. Down here, we have a relative minimum. Relative minimum. Because if I draw a little circle around it, a neighborhood around that point, there are no values that are lower than, or no y values that are lower than -3. This right here is also a relative minimum. Because if I draw that circle around the point -1, 1, that's the lowest y value that we get. This point is not a relative maximum though, because there's that open circle. So we get arbitrarily close to the y value of 1.5 right here, but we never actually get there. If you go further in math, you'll learn that this is called a supremum. Like the limit as we approach it would be 1.5, so the supremum, relative supremum would be like 1.5. But don't worry about that. If it's an open hole, it's not a max or a min. Okay. I believe that's about it for what we need to know. Just a little bit more. Relative just means in that area, it's the maximum or the minimum. Absolute would mean this is an absolute maximum, this is an absolute minimum for this graph, because it's the biggest y value overall, it's the smallest y value overall. This graph here, this function has no maximums at all because it continues increasing, but it has a relative minimum at 2, -1, which is also an absolute minimum. Lastly, sometimes you'll see instead of relative, some people use local, and instead of absolute, some people use global. In this class, we're just going to be talking relative though. Okay, that's about it. Hopefully that's enough to get you through the homework. Thanks for watching, and have a wonderful, wonderful weekend.